Great. Thanks, Denise. And thanks, everyone. It's time to move to our next pre-taped segment. But before we do, I want to encourage our audience to go to the webcast launch page and answer the first polling question. In this question, we ask, what is the most important thing that we can do to help students master algebra? The first answer, put its study more consistently in a real-world context, or 2, ensure that students have the prerequisite skills and knowledge, or 3, ensure that teachers have a deep knowledge of mathematics, or 4, ensure that the curriculum allows for depth, not just breadth, or 5, other. While everyone's working on that question, let's view our second video segment. From it, we can expand more fully on the ideas of multiple representations and a real-world context for algebra.
Welcome to Terry Bullock's Algebra 1 class, a group with lots of energy.
Why was the flip side at all challenging? Or
No, it wasn't. Just pretty much.
We have a whole math program here that has been incredibly successful. By the time the students leave Newport Mill, we have had around 80%, that's our target, completing algebra or higher. And they buy into it. They think it's great. They love the fact that we are a down county school and that they're performing basically the same as a lot of the up county schools where there isn't as many minorities. There's more money in the school through the parents and all of that.
What's the secret to her success? Terry credits the many ways her students are asked to solve problems using words, graphs, symbols, and charts.
When you have so many different ways to present information and for students to understand, they can answer the same questions no matter how the data is presented. So if a student has an equation and they know that they're not very good at solving equations, they know that they can make a table out of the values and use the pattern of the table to help them answer the questions. Versus a student who has a more graphic mind, they can look at the graph of an equation and just find ordered pairs to find their answers and analyze the way that the graph looks.
This is exactly right, according to John Starr, who agreed to demonstrate.
Representations, that's just a word that describes symbols, tables, graphs, ways that we can draw a picture of some aspect of a situation. My cell phone plan, let's say that it's cost me $40 a month for a certain amount of minutes. Mm-hmm. But if I go over that amount of minutes, then I have to pay an extra fee.
Okay.
So I could draw a table, and I could describe that situation, represent it in this table. And I could say, well, okay, if I have 500 minutes, then maybe my cost is this $40 a month. But if I go over 500, like if I have 510, then I might have $40 plus some additional amount to pay for those extra minutes. So I can make a whole table here which describes that situation. That's one representation of it. But that's not the only representation. I could also draw a graph. And maybe the graph might look something like that. That describes something about, in a certain range of minutes here, I pay a fixed amount. But then after that, my bill goes up. And I could also write an equation. I could use symbols to describe this with x's and y's. Understanding in algebra involves being able to move between these different representations. To take a situation like my cell phone bill and describe it, explore it, analyze it, table, graph, or symbol.
That's all fine in theory, but we were wondering what it might look like in Terry's class. Here, she asks her students to look at 3 people who were saving money, but at different monthly rates. Then, she asked her class to compare these rates on a graph.
Okay. And what about Samantha? When does Samantha start off with the most money? When does she have the most money than everybody else? Same people. Melissa?
I think when around the beginning when she was about to match up with Jose.
Okay. From the beginning until she matches with Jose. That's right. Okay. Why does she have the most money in the very beginning?
Because she started out with the most money.
She started with the most money. Very good. Now, which graph was the steepest? Which graph was the steepest? What do you think, Elizabeth? Okay, why is Marcus's the steepest?
Because it has a steeper slope.
Who had the flattest line? Who had the flattest line? Ryan?
Samantha.
Okay, why was Samantha's the flattest?
Because her slope was the lowest.
Her slope was the lowest. And we know that our slope, and what is the slope the same thing as? It's the same thing as our rate of change. And we know that Samantha, even though she started off with a lot, she was only saving $5 each month. So the other guys are going to start to catch up with her, aren't they?
Yeah.
Okay? So for a while she's doing just fine. She has more than anybody else. But then she's going to have less than everybody from that, I think it was 10 months on.
We asked John to watch Terry's class to see if this is what he is talking about.
She's making really strong and explicit connections between different representations of this same problem. So the primary representation that we see is this graph that has the lines on it that intersect, but Terry is really pushing students to connect what they see on the graph and what it means in the real-life context. So Terry starts by looking for observable features in the graph. So points of intersection, which graphs are higher than other graphs at particular intervals. And she's asking students to interpret those features of the graph in the real-life context. What does it mean that this line is higher than this line in the context? So that's really moving them from the graph to the context. She does the reverse of that as well. She asks them a question that's really based in the context: who has more money? And she's asking them to look for features of the graph that allow them to answer that and to justify that choice. So I think she's really working hard to make these connections between the graph and the context, and that looking across multiple representations is really fundamental to what we think it means to understand in algebra.